The safety of persons and property is constantly under threat in mountainous regions due to natural events such as floods, debris flows, landslides, rockfalls, and avalanches. In just a short time, such events can lead to deaths, injuries, the destruction of property, and ecological. Using this combined knowledge and experience, we can verify and further develop scientific theories. A debris flow is a fast-flowing mixture. Various solution concepts exist to reduce the destructive effect of debris flows. For instance, metal girders were installed in a torrent to separate debris and water. But because they are not flexible, they can be easily destroyed by large boulders. Often an attempt is made to stabilize the torrent bed with concrete check dams. The idea is to break the debris flow and thereby reduce its energy. With this system, though, the abrasive effect of the debris results in an unsatisfactory service life. The latest and most promising technique uses ring nets. Just as with a tea strainer, water is drawn off, leaving behind the solids and causing the mixture to company Geobruck in Romanshorn collaborates closely with WSL. It manufactures the world's strongest ring net systems, which have been installed for test purposes in a debris flow barrier. The results from the Illgraben debris flow test site in Switzerland have been positive. The barrier was filled to the brim by a muddy debris flow event, retaining approximately 1,000 cubic meters of debris. The debris flow barrier was filled to excess with several tens of thousands of cubic meters of debris. As was proved, a multi-level barrier arrangement can hold back larger retention volumes. October 2006. On the basis of the successful first test series, a new multi-level barrier was constructed in the Merdanson torrent. It overflows, and the debris flow is captured by the second barrier. Our calculations indicate that we can hold 2006. Construction is complete. A serious event on January the 1st, 2007. A debris flow thunders down into the valley. Researchers and Matthias Denk from Geobruck are analyzing the results. We are very satisfied with the results. The event was simulated with Faro software. The calculated data agree well with real-world experience. The filled Merdanson barriers will not be cleaned out and will serve as protection from undesirable erosion in the torrent bed, in the flanks, and in the foundations of a 10-meter high. It is simple and efficient. The special V-shaped flank anchorage, the support ropes, ring nets, brake elements and abrasion protection together form a well-tuned, compact barrier system. The relatively light materials can also be flown in with helicopters and installed in impassable terrain, such as, for example, high up in the catchment area of a torrent. Usually, a torrent does not have to be rerouted or dammed. Drilling work is required only in the flanks. A light drilling rig suffices, enabling anchors to be installed even in difficult soil. In the debris flow release zone at Hasliberg, Switzerland, a multi-level construction with a series of 13 barriers is being built for the first time. This provides a total retention capacity of more than 10,000 cubic meters. An additional advantage is the low visibility of this type of protective measure. It has also proved its worth as a driftwood barrier for preventing stoppages. After events, filled barriers are simple to empty using a bucket excavator. Each installation can be simulated using Faro software to determine the optimal solution in advance with low dimensioning costs. The future climate model is not very promising. Global warming of the atmosphere is a certainty. Geobruck debris flow barriers are suitable as bedload samplers, filled bed and flank erosion protection, or as energy absorbers.